All right, so what I want to talk to you about in this lesson here is balancing equations. When we talk about, we've been talking about writing chemical formulas recently, okay? And the goal is to write chemical equations with these formulas. So I want to just give you some background and just help you explain why we need to balance chemical equations. I don't know how many of you have made cookies or done any baking. Put up your hand if you've ever made cookies, either on your own or with a parent or a friend. Okay, that's most of you. So when you look at a recipe, okay, when you look at a recipe, there's always amounts of each ingredient that you're supposed to mix up. Always. You never see a recipe that just says add flour, eggs, salt, baking powder, butter, sugar, chocolate chips, and good luck with the rest of it. Just guess on how much you're supposed to put in, and hopefully you'll get some edible cookies, right? So you never see that in a recipe book. There's always amounts. A skeleton equation is a term that we use for just the substances themselves that are involved. And this right here is what a skeleton recipe would look like. We know we need these ingredients, but the important thing, as I just mentioned, is you need to know how much, right? How much of each. We certainly wouldn't add the same amount of each of these things. Can you imagine adding, a cup of flour and a cup of salt? Yeah, I don't know. And a cup of baking powder? And how do you do a cup of eggs? I don't know. But anyways, you're going to need some amounts, right? It is also important to note here that at the end of this little skeleton equation, or near the end, there's an arrow. In chemical equations, we never have equal signs. We always have arrows. So these are the ingredients or the reactants on this side. Okay, so these are called reactants, and you should remember a lot of this from Science 10. Okay, so the reactants are on the left side, and those are the things that react together to produce one or more things on the right side. And what are these called? Yeah, they're called cookies, right? Products, okay? Reactants on the left, products on the right. And of course, we always use an arrow, not an equal sign, okay? Because this arrow means, combines together to produce, or yields, or reacts together, to produce, sort of thing. All right? So that we know that we need specific amounts of each of these ingredients to make good cookies. And this is exactly what balancing chemical equations is like. So you've learned in Science 10 about balancing equations. You have some experience here. Balancing a chemical equation is simply making sure that there's the same number of atoms of each element on both sides of the equation. So before you copy down these rules here, let me just give you an example. Okay, if we have hydrogen, and this is actually molecular hydrogen, okay, or elemental hydrogen, and it always is H2 when it's by itself, when it's not an ion, it's always H2. And let's say we have elemental chlorine, and it's another one that always is Cl2 when it's by itself. And this produces hydrochloric acid. Okay. Now this would be gas. Do you remember using these little letters here last year to signify the states of matter? Okay. So if you had hydrogen gas and a little brackets there with a G, that's part of a chemical equation, the states of matter, and chlorine gas, it would produce some hydrogen chloride. Okay, and this would be, well, if it's just gas and gas, I guess we'll say this is aqueous hydrogen chloride. Or would it be liquid? I guess, anyways, either one. But you could put a state there too. So actually, I'll have to check on that. I think that could be liquid. Because aqueous means dissolved in water, which we have no water in this equation. So I think we might have to write that as liquid. I'm going to check on that, though. I'll get back to you on that one. Okay? So liquid HCl, let's just say that. But the point wasn't the states of matter. The point was the balancing part, okay? So I have how many hydrogens on this side of the equation? How many? There's 2, because of the subscript there, that means there's 2 hydrogens on this side. How many hydrogens do I have in total on this side? I have 1. So that's an imbalance right now. So in order to balance those, we would need to use coefficients, not subscripts. Need to use coefficients. And in this case, I have 2 here, so I'm going to need 2 of these things to make my 2 hydrogens. See? This is now I have 2 hydrogens on this side. And I also have what? Now, 2 chlorines. And so that makes sense over here. I actually have 2 chlorines. So this right now is balanced. But what I want you to do is to finish it off, is I want you to put all of the numbers in front of each substance. So if there's a 1, I need you to write a 1. Okay? And now, in the past, I'm not sure what your teachers have required of you, but I need you to write 1, 1, 2 in this case. Okay? Because A, I know that you know you're done, and not just have forgotten to put a number in there. And the other thing is, what we're going to get to in physical science here is something called stoichiometry, which the molar ratios of all of the substances involved in a chemical reaction is very important. So these numbers are all going to be very useful. All right. So there are some rules, some tips, I guess, to balancing, which you might want to write these down. There's 4 of them that I've just kind of summarized and mentioned here. So number 1, it's a good idea to balance metals that are in compounds first, like magnesium, calcium, potassium, lithium, strontium, barium. The metals that are in compounds, that's a good idea to start with those. So yeah, you might want to write these steps down. And again, if you want to title this as just steps and tips to balancing equations. So balance metals and compounds first. Number 2, if there are any polyatomic ions in a compound, it's a good idea to balance the entire polyatomic ion on both sides. So if, for example, you have sulfate, sodium, let's say we have sodium sulfate on this side, and it reacts with something else here, and you end up with, iron sulfate over here. Okay, and let's say this is, 2 and this is 3. So if we have this sort of thing, what I'm suggesting is look at this polyatomic ion as a whole and balance that as a whole. So there's 3 entire sulfate ions on the right side, and there's only 1 entire sulfate ion on the left side. So that's a good place to go there. So you can put a 3 here to make 3 sulfate ions, just like I have 3 sulfate ions over here. Do you get that? Instead of doing individual elements, it gets long and complicated, and you can simplify things quite a bit by balancing entire polyatomic ions. Okay. It's a good idea to save the lone elements. So if you have O2 or Cl2 or H2, it's usually a good idea to save those for last. Because it's easy to just say, yeah, I need 2 of these, so I'm just going to put 2 in front. Or, you know what I mean, I need 4 of these, so I'm just going to put 4 in front of that one, and we're done. So if you save those for last, it's a good idea. Usually oxygen or other elemental metals are in an equation. Save those ones for last again. And then double check that you have all atoms accounted for. Hydrogen is another good one to leave towards the end, because hydrogen is usually in a lot of different compounds, and you don't want to chase around the hydrogen and the oxygen first. So, anyways, that's kind of the simplest sort of steps and tips that I could give you, and then of course double check at the end. Okay. The other piece to this, and sometimes students just say, well, how can I just add another compound to this mix here? You don't have to worry about adding randomly more atoms when you're balancing, because really inside this inside the beaker or inside the container, there are literally trillions and trillions of different atoms, and trillions of atoms that are available to just kind of pull in and add to this kind of big recipe, right? So don't worry about that. There's always going to be enough for you to write a balanced equation. Even if if you balance the equation, you need 1 of these molecules and you need 75 of these ones. Don't feel bad like, oh, am I going to have enough? There's lots. Okay. All right. So just like in a recipe, if you need more sugar, you just go to the bag of sugar, and that's good. Okay. All right. So let's get some practice here. Let's just start with number 1. Don't copy them all out just yet, but let's start with number 1. And let's take a look at this one. This is, what element is this? Aluminum. This is nitrogen, and this is aluminum nitride. Good. Aluminum nitride. All right. Okay. So, once you've got that kind of skeleton equation written down there, let's just take a quick check. Aluminum, okay, I have 1 over here and I have 1 over here. That's good. Nitrogen, I have 2 over here and I only have 1 over here. So, this is important too. You can't do this. Oh, I'm just going to add another, and now I'm done. Okay, you can't do that. You cannot add elements or add compounds, like different compounds. You can't just add a different compound, okay, to a skeleton equation like that. What you do is you use your coefficients, okay? So what we're going to do is I need 2 over here, so I put a 2 in front right there. All right? So you have to use coefficients. You can't, here's the other thing you can't do, you can't just say, oh, if I had this, that would be awesome. There we go, done. Because, again, you're changing the actual compound, right? So we're just changing numbers of compounds, just like in the recipe, right? If you don't have enough sugar, you can't just say, well, I'm just going to use salt instead. Or you can't, you know what I mean? You can't just add something and expect this recipe to work. So you can't change the nature of the compounds, okay? But you can change the number of them. So we do this, and that now balances off the end, so I'm done, right? Oh, I'm not. Why not? Oh, that also changes the aluminum. Look at this too, also changes the number of aluminums. So what do I got to do over here? 2 there. And then to finish off, yes, please write the 1 there, and that means you're done. Double check, 2 aluminums, 2 nitrogens, and 2 nitrogens. No, in like brackets for the when you put the numbers? No, you don't have to put brackets there. Yeah, just make sure it's clear. Oh, yeah, as long as it's clear. You don't see brackets. You don't see brackets in chemical equations, so don't. The question was, do you want us to put brackets around here? Because apparently you had one of your teachers did that. No, you don't have to do that. Just make sure it's clear. Yes, but these brackets are different. Remember, this is part of writing the formula correctly. This means that there are 4 of these whole entire groups of things here. Yeah, so don't just add, you don't have to add brackets around your moles. Okay, around your numbers there. Okay, let's do number 2. Actually, yeah, let's do number 2 together. Iron, okay, there's 3 over here, and I've got 1 over here, so I put a 3 there. And, oh, this one's going to be easy, isn't it? Look at there's 4 oxygens here and 2 here, so what do I got to do? 2 there. Am I done with balancing? Is that done or no? Okay, so I put a 1 there now, yeah. So is that done? I've got the right numbers of things. 3 irons, 4 oxygens, 4 oxygens. That's balanced. Okay. Okay, does anybody have any questions so far? All right, why don't you do number 23? Try number 23 on your own. That's a bit tougher. Try number 23 on your own. Remember the rules. Remember the rules, because, well, we don't have any lone elements. Do we have any polyatomic ions? Nah, not really. Okay, so just start going 1 element at a time, and you might have to go back and forth, and you might have to change a number here and there. Okay, so go ahead and give that a shot. So yes, there are, if you're taking a look at oxygens, there are 4 plus 7 oxygens. So there are 11 oxygens on this side. Okay, so you have to make sure that the total number is balanced. Okay, so that's a good question. And over here there are 14, so we're not balanced yet. But remember, leave oxygens because they're in multiple compounds. Leave that one till towards the end. Okay, start with some of the compounds that are only in, 1 compound each. Like for example, hydrogen. Here you can start with hydrogen, or you can start with phosphorus. Right? You can chlorine, whatever. But you might have to go back and forth. Okay, you may have done it a different way, but I'm going to, for those of you that are struggling here, we'll just do, okay. So phosphorus has 4 here and only has 1 over here. See that? It's just 1 phosphorus. This 4 is for the oxygen, this 3 is for the hydrogen, so there's only 1. So what if you did this, okay? Let's put a 4 there. Now that's going to affect some other things like hydrogen, right? So let's see, hydrogen. I've now got how many hydrogens here? I've got, well, actually I've got 4 times 3, not 4 plus 3. I actually have 12 hydrogens here. Why? Because in each compound, I have 3 hydrogens, and I have 4 of these compounds. So it's actually 4 groups of 3. So that's 12. Get that? All right. So that's 12. Now, I'll go back to the other side, and I'll say, okay, I only have 1 hydrogen over there. So what if I put a 12 right here? Now the hydrogens are balanced. See that? But it also affects chlorine and oxygen. So oxygens are all over the place, so let's just save those. What about chlorine? I've got 12 chlorines now. If I go to the other side, is there any way I can get 12 chlorines from here? Yeah, times 6. Okay. So now let's check, so now the hydrogens and chlorines should be, and the phosphorus should be all balanced out. Let's check the oxygens. I have 12 times 4, that's 48 oxygens here. I have 10 oxygens here, so I have 58 in total. How many do I have here? I have 16 oxygens, and I have 42. So what's 16 and 42? 58. So I have 58 oxygens here, and I have 58 oxygens over there as well. So am I done balancing? Yeah, and then you put the 1 here. So we'll double check, 12 hydrogens, 12 hydrogens, 12 chlorines, 12 chlorines, 4 phosphorus, 4 phosphorus, and then I counted the oxygens. Okay, so there you go. For 23, the ratio of coefficients here should be 12, 1, 4, 6. Okay, got that? All right, so I want you to copy down the rest of these here. So these 7 questions, copy those down, and yeah, I want you to finish those for homework.